I haven't done this in ages. Oh! Don't do that! Dear Tim and Moby, solving and graphing inequalities is totally confusing. We need some pointers. From Noah and Eric. Well, you can see an inequality at work here, right on the seesaw. My backpack weighs about 15 pounds, and Moby's weighs 20 pounds. The weight of Moby's backpack is greater than the weight of mine by 5 pounds. Now, since Moby removed that 10-pound weight from his pack, mine is the heavier one. When I take an identical 10-pound weight from my backpack, our backpacks have the same 5-pound difference we started with, and the inequality is the same as when we started. We've both subtracted 10 pounds from the weight of our backpacks. So, an inequality remains true when you subtract the same amount from both sides. Right, Moby, inequalities also remain true when we add the same to both sides, and when we multiply and divide each side by the same positive integer. But when it comes to multiplication and division with negative integers, you have to reverse the order symbol. Okay, now we use division to solve this inequality. Negative 5x divided by negative 5 is x, and 10 divided by negative 5 is negative 2. So we've got x is greater than negative 2. But that order symbol needs to be reversed because we divided both sides by a negative number. That's the rule. That makes sense. Negative 5 times negative 2 equals 10, so any number less than negative 2, like negative 3 times negative 5, should equal more than 10. Now, say we need to graph that solution, x is less than negative 2, on a number line. X can't be equal to negative 2, so we make an open circle around the negative 2 mark. And x is any number less than negative 2. That arrow means that any number less than negative 10 could also be equal to x. So, that's a graph of x is less than negative 2. To graph x is less than or equal to negative 2, we'd close up the circle. That tells us that negative 2 is included in the solution. So there you are, solving and graphing inequalities. My backpack.